Of the 100 or so atoms that we know of that comprise the elements on the periodic table, we know that they're arranged with these numbers in the upper right-hand corner: 5, 6, 7, 8, 9. Well, these numbers come from something called the atomic number. And the atomic number organizes the periodic table, and the atomic number is the number of protons in the nucleus. And so from left to right, top to bottom, 1, 2, 3, 4, 5, 6, 7, 8, 9, you can find on your periodic table that it's organized all by the addition of protons in the nucleus. That's what makes these elements way down here at the bottom be way heavier or more massive than the elements up here at the top, because they have lots more protons in the nucleus. And remember, each proton has a mass of 1 AMU. It also adds more neutrons to it as well, but the atomic number is symbolized many times in the lower left-hand corner when we draw a atomic symbol of an element. Now, on your particular periodic table, it's in the upper left-hand corner up here. But let's talk more about this symbolism right now, and we'll come back and we'll look at these on the periodic table in a second. So there's also a mass number for every element, and they're not on the periodic table. The mass number is the number of protons plus the number of neutrons in the nucleus. For example, there is a type of carbon that has 6 protons in it. That's what makes it be carbon. And then it has 8 neutrons in it, and it's called carbon-14. And so you'd put the mass number in the upper left-hand corner right here, telling you the number of protons plus neutrons. So to find the mass number, it's always protons plus neutrons, or if you know the mass number and you want to know the number of neutrons, just put the protons in there, and then you can do some quick math to figure that out. Since there's carbon-14 right here, and you can see in the book there's this thing called carbon-12, well, there must be several different types of carbon in the world, and there are. These different kinds of carbon that exist in the world, naturally or sort of unnaturally, or for most any element, are called isotopes of one another. And if we look at table 2.2, we can write down the symbol of these different carbons, how many protons they have, how many electrons they have, how many neutrons they have, and then their mass number. So for carbon, there would be a certain carbon that has 6 protons, 6 electrons, and then it would have 5 neutrons, and 6 plus 5 would give it a mass number of 11. Then there would be this type of carbon that has 6 protons, 6 electrons, and 6 neutrons. This is the most common type of carbon in the world, and this is called carbon-12. You'd have a little 12 in the upper left-hand corner. Now you could put a little 6 down here as well to indicate that it has 6 protons, but since it's carbon, or got the symbol C, it always has 6. There's carbon-13, 6 protons, 6 electrons, and then it would have 7 neutrons. 13 would be its mass number. And then there's carbon-14 that we talked about, 6 protons, 6 electrons, 8 neutrons, and it would have 14 for a mass number. These different types of carbons are all called isotopes of one another. Isotopes. These 4 different isotopes make up a sample of carbon that you would like, for example, dig out of the ground. Another example of different isotopes would be uranium's isotope. Uranium-235 is what most uranium is that would be mined or dug out of the ground. And then there's also uranium-235, and this is the type that's very radioactive and would be used in nuclear fuel. And so when they talk about enriching uranium, what they want to do is they want to get a sample to have more of this U-235 in it and less of the U-238 in it. More on these different types of isotopes in the next video.